Hey there! Today I'll be talking about superconductivity and its role in the future. This is for my ENG2003 course at Lausanne. In this day and age, humanity is reliant on electricity to survive in the world, or more specifically, we live off of materials that can conduct electricity, such as copper. It powers our lights, our appliances, our devices, and more. It's also significant for electromagnetics. But as important as it is, unfortunately, like most things, it is not perfect. As you may know, electricity is defined by the flow of electric charge through an electrically conductive material and the power it delivers. With standard conductors, there is some resistance in the material, meaning that not all of the current can pass through. Since the more resistance there is, the more collisions there are. We lose energy due to these collisions in the form of heat. This energy loss is generally not a problem, as the heat energy is what powers our technology. However, there is a limit to how much the electric current may travel before it dissipates entirely as a result of the resistance in the conductor. This energy loss is a problem when it comes to transmitting power for long distances, like from one side of a country to the other, or when technology calls for higher current densities. And this is where superconductors come in. Before we talk about how it will serve us in the future, I'll first talk about what a superconductor is. Superconductivity is when an electrically conductive material has no resistance and current is able to pass through freely with zero energy loss, unlike the standard electric conductor. It is a property discovered by the Dutch physicist Heike Kamerlingh-Onnes. To understand why this happens, you must understand why resistivity happens. Raising temperature can increase resistivity because it creates vibrations in atoms, which makes it harder for electrons to flow. Imperfections or impurities, they are obstacles which make it harder for electrons to pass through. Lastly, the density of free electrons, as more electrons means more collisions. Superconductors have no resistance because the temperature is typically reduced to approximately negative 300 degrees Celsius under what is called the material's critical temperature, and it is different for different materials. Additionally, the free electron density in a superconductor is less than that of a standard conductor. Here is the comparison of lead, which is a superconductive material, versus copper. A couple of decades after superconductivity was discovered, these two German scientists found that superconductors can repel magnetic fields when in a superconductive state. By the way, this property is called the Meissner effect. This property is what makes electrical generators possible. Some technology that use superconductors are maglev trains, microchips, and MRI machines. Superconductivity is a concept that we still do not know a lot about, and scientists are still making new discoveries on it today. Recently, a research team at the University of Alabama Huntsville have developed a ceramic which is superconductive at 92 degrees Kelvin, approximately negative 181.15 degrees Celsius. This is great as superconductors are chilled with helium, which can be quite costly. This new ceramic gets superconductive at a higher temperature than nitrogen, which is an element more accessible than helium. Now, where will we see superconductors in the future? In the future, we hope to be able to utilize superconductive properties for power transmission. This property alone would reduce costs of power transmission drastically across the globe. It may also potentially be the future of transportation, like the maglev train, which levitates and moves with the help of superconductors' magnetic properties. We are hoping to normalize and optimize transportation like the maglev train in cities around the globe, as transportation would operate faster as the rail will have zero friction, the energy usage could potentially be reduced significantly, and last, the greenhouse gases will be less. For now, we are still finding out more about superconductors and how we can modify it to be used casually. Maybe one day we will be able to find a way to use its properties to create a device that seldom needs to be charged. Who knows what other ways we can use it? But for now, these goals remain a challenge until we find a way to implement superconductivity at room temperature or higher.